So we have a hard problem today. Given some strings ABC, DEF example, and maybe BBC. So this is strings, and then we have queries that are suffixes like EC. And in each query we have to match all the strings with this longest common suffix or prefix, suffix, yes, suffix. So for example, the query can be BCA, but the match is exactly BC. And we then find all of this, and then we find the shortest one, and then we find the first one. Now the solution is a trie, T-R-I-E, trie. We, for all strings that are given, we go from the end to the start, and we collecting character by character them into trie. So the trie is like letters, characters from A to Z. Then each letter can be a root of some subtree, and it has its own A to Z children. So can have it like this. And if we going to match some prefix or suffix we have in character, like C, for example, and C can go to like B or D. So this would be two children, and so on. So this is a trie. It has 26 children in each node. Based on that, character is SCI, but you can use more interesting characters in a string than just 26. And you can use hash map for this. Basically each node would have its own hash map, or you can use just array of 26, and that would be okay for this problem. So when you put all of these words into trie, use a query. The query part is simple. You go and you check from the root of the trie. You go and you check where it should go, and the final node would be the common suffix, common between the query and the words that we had in trie. And additionally, we can store in this trie some information, like we can store the index I, just to check what was the position. And for this problem, because we want the shortest one and the first one, we can solve the shortness when we collect the trie before the query. It would be just simpler to do this in this first step. So instead of collecting all of the possible indexes, we just use I as the first one or the shortest one, and we override this index. Let's look at the code. This is a Kotlin one. So uses trie as a class of a hash map. It is a recursive version, like T derived from the hash map char T. Then initial trie has index of minimum. You have to do this, and when you're building this trie, you have to overwrite the index. I use a stack to backpropagate, but this wasn't necessary because there is no merging logic. You can do overriding just as soon as you have an instance of current node. And final query is just go from the end position and query the current node for the current letter, and if it's 0, then that means we finish the common prefix. And in Kotlin, this question mark and break wouldn't nullify the T, it would exit early, so T is never null. Now this is was my accepted, and let's look at the shortest version. This is the shortest version of Kotlin. So I dropped the data class and just used class, and all other things are basically the same. Use run to drop return, use reversed just to have less characters in my solution. And I don't use stack, I just override the index as soon as I have current node. This is a Kotlin, and let's look at the Rust. Okay, the Rust has hash map version. This is a hash map. So it's defined a struct that is also recursive. It has useSize and hash map inside. Then we have to find the root that is smallest length position, and then we doing the same by its reverse and insert hash map new, so it's kind of same as a Kotlin one. And interesting is the arena solution. So instead of defining a hash map, we are defining this arena array, and 26 letters inside it. This is the first value, and then instead of inserting into the hash map, we insert into this arena. So if it's not inserted, we do the insertion. And the query is the simplest. Just check that the value is 0 and break. Okay, that's it for today.